Okay, in this video we are going to be looking at our first circuit elements and coming up with some of the symbols and then doing one or two basic examples with those new symbols that we have. So first off, let's just dive right into this and go ahead and go over our first one here is voltage sources. Voltage and actually we'll do both of them here, voltage and current sources. Well, the first thing we should point out is that there's really two types of sources. And the first one that we're going to look at, which is the one that most of you are probably already familiar with. You might not be familiar with the name, but they're called independent sources. And the symbols for these are two terminals here and a circle. And then depending on what we want, whether it's a voltage or a current, determines what we put in the symbol here. If we do a plus minus, this is a voltage source. And then if we do the circle but then put an arrow in it, this is simply a current source. And of course we'd have a current I. So we put a label next to them in order to determine what the voltage or current is. Now, as I said, these are the ones you're probably familiar with, because especially with voltage sources, like if you're talking about a battery, we can use this symbol to represent a battery. Although I will put in here that there is another common symbol that is used, and this is another common symbol used for voltage, and sometimes they prefer using this symbol to represent a battery as opposed to this symbol up here. But in reality, you can use either one. There's no set rule in electronics as far as which one is proper. There are what some companies might have policies or procedures how they operate. In other words, they might operate with the understanding that this symbol here is always referred to as a battery, and this symbol might be referred to as, for instance, instead of it being a battery, maybe a benchtop DC supply or even an outlet. And then we can also have a current source here, but now the current sources we don't have an additional one symbol like we have for the voltage. We just have this single current source. Now, one thing here, let's just do a quick example here with these independent power supplies. And if we have something set up here, this box is just representing, a circuit or something like that. And so I've got a 3-volt power supply that I'm applying to the circuit. And in this case, it's going to be a very simple question here. It's just find V1. Now, this particular configuration is something that's called parallel, which we will talk about in more detail in a few lessons. Because there's something that's going to be very critical about a parallel configuration. But for now, we can just look at it as, well, we have two items here, and because this plus minus of my voltage source, this is of my voltage source size, because these pluses match up like this, we would get that V1 is equal to 3 volts, because it's in the exact same configuration. Now, if I were to then modify this question instead and put another voltage here. Remember, when we label these voltages, we're not saying whether the voltage is positive or negative, we're just labeling how we're measuring it. So if I label it like this V2, well, it's still going to be a value of 3, but in this case it's negative 3 volts. And if you think about it, basically what you would be doing, think about measuring a battery, for instance. You'd be putting the positive terminal of your voltmeter on the negative terminal of the battery, and then the negative terminal of the voltmeter on the positive terminal of the battery, which would again, of course, just give me a negative voltage out there. So it's negative 3 volts. Okay, so again, I keep emphasizing this, but voltage, it's very important. We say it's always measured with respect to a reference. And so it's always important to know, how you're connecting these up, because it will affect whether you get a positive or negative reading. All right. So the key thing to also remember about the way we draw these sources here is we assume a voltage source can supply as much current as we need. So in other words, when I have a voltage source here, and I have maybe 5 volts here, and I've got some current called I going in here, I is basically whatever the circuit needs. Now, from analyzing a circuit with pen and paper and pencil, that's an okay assumption to have, but in real life that does not happen. And it's an easy thing to see for yourself, is that you can actually, and maybe we'll even do a lab experiment with this, where you can have a battery where a battery, for instance, just a AA battery is 1.5 volts. But if you're trying to start drawing too much current out of that battery, that voltage won't stay at 1.5. It will actually drop if you draw too much current. It doesn't mean that it's no longer at 1.5. It just means it can't supply 1.5 volts at that current. And then if you had less demand on that current, it would go back up to 1.5. So even though in practice a power supply can, on pen and paper, a power supply can supply as much current as needed, in practice that is not the case. But it makes computations easier. And the other thing is we're going to do the same thing for a current source. A current source can have as high a voltage potential as needed. Now, you will say that when we do pen and paper, we will have current sources, but you might say you don't really encounter current sources in real life. And to some extent, that is somewhat true. I mean, most of the time we're talking about a battery, and we think of a battery as a voltage source, not a current source. But to say that you can't have current sources is incorrect. I mean, you can get them. They're just not what I would consider a standard component that you would be buying. But you can absolutely buy power supplies that are just, okay, I'm going to purposely supply, 1 amp of current to the circuit. And it's not necessarily that you're supplying, you have a voltage potential, you're just supplying a current into the circuit. So that's absolutely possible to do. They're just not very common. Now this is independent power supplies. We said there are 2 types of power supplies. Let's look at the other type, which is dependent power supplies. Now, just like independent, they'll be able to supply as much current as needed, and as much voltage potential as needed as well. But these here, the key thing is the value depends on another circuit element. So the value of these dependent power supplies, hence the name, depends on another circuit element. Now, the standard way we draw these here is a little diamond here. And again, depending on the type of diamond here, you'll have a plus minus. Now I'm going to draw 4 of these because there's really technically 4 types of dependent power supplies we can have. And so 2 of them are voltage sources and 2 of them are current sources. And the reason we have 4 of them is the way these would be written is there will be some K times potentially a voltage. So the value here, this voltage source, depends on the value of Vx. But now, one thing that gets sometimes some people confused is you don't have to depend on a voltage. For instance, my voltage source could be dependent on the value of a current. So I could have, for instance, the voltage source being K times some current X. And then we have the exact same thing for these current sources. I could have it dependent on a current, Ix, and we could also have it dependent on a voltage, Vx. Now at first you might say these dependent power sources, power supplies, don't seem to be very useful, or where's the practical application of this? I mean, when will we ever have a power supply that depends on another one? And without going into the details, because we'll cover this in a later course, I always like to give you a little bit of motivation for this. Transistors behave as dependent sources. Now, without going into more detail than that, that's as far as I want to go for now. But that's one of the reasons why we're interested in dependent power supplies, is because transistors behave as if there's a dependent source in them. Okay? Alright, so let's look at an example or two here before we finish off this particular lesson or video. So let's first look at this example. Here, I have to find it in my notes. Sorry about that. Okay, so this is the circuit we're going to be looking at here with some circuit elements. and this power supply here is 9 volts. So here, what is the value of VL? What is the power across component, instead of across the load? Alright, so what is the value of VL? So we're trying to figure out this voltage here. Well, just like we had previously, and I'll slide back up here, remember when we had things in this configuration, slide back up a little bit here, when we had 3 volts here, we saw that V1 was also 3 volts. So we have the same thing going on down here, it's just we have a slightly more complicated circuit. It's not very complicated, but it's a slightly more complicated circuit. Now, there's many ways to approach this problem. I always kind of like to approach from my answer backwards here, in the sense that, well, what am I looking for? Well, I'm looking for VL. Well, from this here, we can see, just looking at the right-hand side here, so I'm just looking in this portion right here, we can clearly see that VL is simply equal to 3 Vx, because it's equal to this dependent power supply. Now, of course, I don't know what 3Vx is currently, but I can clearly see that looking at the left-hand portion of this circuit, that Vx is equal to 9 volts. And I forgot to give you one piece of information here, which we'll get to in a second. So then we can clearly see, just substituting here, we can get that VL is equal to 3 times 9, which is 27 volts. Now make sure to include units on this, on answers. That's always a silly way to lose a point or something, is to forget a unit. So what is the value of VL? That's part A, but I meant to add one thing here. If I equals 2 milliamps. Forgot to add that in there. I need to tell you what the current is. Well, that's, at this point, easy, because I have the voltage now as 27 volts, and we know power is just voltage times current. Now, let's make sure the current is in the proper form before I use it here. The current's arrow is pointing in to the plus sign, so that means here power for the load is simply just this current that's entering it times VL, because the current is entering the positive terminal. So this would be 2 milliamps times 27 volts, which, doing this computation, gives me 54 milliwatts. Now, the problem didn't specify to do this, but I just want to emphasize again, we talked about this in a previous lesson, that this is now a positive value, which means that this circuit element is absorbing power. It's not delivering power, it's absorbing power. Alright. Now, one thing that sometimes gets people here, and I'll ask a question here to end this video, and I'll answer this question as well. Can a power supply absorb power? And a lot of people might initially say no, because of the fact that we're saying supply. So a power supply clearly supplies power. So how could it absorb power? Well, we got to be careful with things, that the way we've named them, just not letting that make it so that we automatically assume something that's not the case. There's absolutely a chance that a power supply could be absorbing power. The answer to this is yes, and a practical example is recharging a battery. rechargeable batteries both supply power and absorb power, because they supply power, of course, when you're using those batteries to run a circuit, but they are absorbing power when you are recharging them. So we have to be careful when we say power supply to think that a power supply can only deliver power. It can also absorb power. So we have to be careful with that. And the easiest way to do it is not worry about it, is just follow the sign conventions we've developed. If you do your computations correctly and you have a positive power, that means you're absorbing power. And if you do your computations correctly and you get a negative power, that means you are delivering power.